On Wednesday, April 1st, 2026, NASA launched a crewed mission to the Moon carrying 4 astronauts. This was the first time that humans had reached the Moon since the Apollo 17 mission in 1972, more than half a century earlier. The new mission was named Artemis II and was intended to mark a new chapter in space exploration. Some people have said that they have already been to the Moon. Why not return? I can tell you that they will be returning now. But what is the purpose of the Artemis mission? How does it differ from the Apollo missions that preceded it? What steps will be taken afterwards? Welcome to Random Channel. If you're new to the channel, don't forget to subscribe and turn on notifications to receive regular updates. I hope you enjoy the video. The Artemis II mission launched from the Kennedy Space Center in Florida, aboard the Orion spacecraft at 6:35 a.m. on Wednesday. The current Artemis mission is not intended to land on the Moon, but rather to orbit it and remain close to its surface. The third Artemis mission will be the one to land on the Moon. The Orion spacecraft's crew consists of Mission Commander Reed Wiseman, a fighter pilot who previously spent several months on the International Space Station, and Victor Glover, who was part of the inaugural crewed mission of SpaceX's Dragon spacecraft to the International Space Station. The crew is completed by 2 mission specialists, Christine Koch, an electrical engineer, and Jeremy Hansen, an astronaut from the Canadian Space Agency and a fighter pilot in the Canadian Air Force. Thus, the Orion crew is complete. The Orion spacecraft, which carries the crew, consists of 2 main parts, the crew module and the service module. The crew module is the cone-shaped section in which the astronauts will live throughout the mission. While its exterior resembles the older Apollo capsules, it is significantly more advanced. The interior living space is no more than 9 cubic meters, providing a comfortable area for 4 people. While the exterior of the capsule resembles the Apollo capsules, the interior features the latest and most advanced screens and control systems. All of these features facilitate the crew's monitoring of everything on board. Most importantly, the capsule is externally encased in an advanced heat shield made of a special material designed to dissipate the heat generated by friction with the atmosphere. The second part is the service module, which is considered the heart of the spacecraft. Contrary to popular belief, this module was designed and built by the European Space Agency, ESA, not NASA. It houses the solar panels that generate electricity for the spacecraft, as well as the water and oxygen tanks for the astronauts. It also contains the main engine. For the basic maneuvers required to guide the vehicle, the rocket that launched it from Earth was the Space Launch System Mega Rocket, abbreviated to SLS. This heavy-lift launch system is approximately 100 meters long and, when fully fueled, weighs up to 2.5 million kilograms. It is considered the most powerful launch vehicle built to date. Its primary stage relies on 4 main engines, and 2 solid fuel booster rockets are mounted on the sides. When the main engines and booster rockets work together, they generate a thrust of approximately 40 million newtons. The primary role of the SLS rocket is to provide the capsule with the powerful boost needed to escape the Earth's atmosphere and gravity. Immediately after launching from the ground platform, the rocket will carry the Orion capsule into low Earth orbit. At this stage, the crew will spend an hour checking that all essential systems are functioning properly following the intense vibrations experienced during launch. Next, they will fire the upper stage engines to change the orbit to a high elliptical one around Earth. This orbit takes approximately 24 hours to complete 1 revolution. During this time, the crew will test the life support systems, the carbon dioxide removal system, and the manual control systems of the spacecraft. This must be done while they are still relatively close to Earth, in case any problems arise and they need to return immediately. This phase has already passed without incident. Afterwards, the spacecraft must orbit the Earth twice before heading towards the Moon. In order to break free from Earth's gravity, the crew must fire the final stage of the launch vehicle for 20 minutes in order to provide the necessary thrust for the capsule to escape gravity and travel towards the Moon. From this point, the spacecraft will enter a state known as a freefall trajectory. The concept behind this trajectory is quite simple. The spacecraft will travel towards the Moon at a specific speed and angle. The Moon's gravity will then spin the spacecraft around it and return it to Earth naturally, eliminating the need to ignite the main engines. This trajectory is the safest possible because it ensures the crew's return to Earth, even if all the engines were to fail suddenly. During the orbit, the distance between the spacecraft and the lunar surface will be much greater than in previous Apollo missions. While Apollo missions only reached an altitude of around 100 kilometers, Artemis II will travel between 6,000 and 10,000 kilometers above the lunar surface. This will be the furthest distance ever traveled by humans, breaking the record set by Apollo 13. Finally, during the orbit, the spacecraft will pass behind the far side of the Moon. At this point, communication between the crew and Earth will be completely lost. The radio will not transmit any sound, and ground control screens will not receive any data. The crew will be isolated from the rest of the world for around 45 minutes. Once the spacecraft has completed this orbit and begun to reappear from the far side, the other part of the satellite will restore normal communications. After this orbit, the Moon's gravity will have provided Orion with the necessary boost to return to Earth in a straight line. During the return journey, the Orion capsule will detach from the service module, which will have completed its mission, and burn up in the atmosphere as it approaches Earth. The capsule carrying the crew will begin its descent to Earth at a speed of around 40,000 kilometers per hour. This incredible speed will naturally generate tremendous friction with air molecules, and cause the temperature of the capsule's outer shield to rise to around 2,800 degrees Celsius. This temperature is sufficient to melt most metals. However, as previously mentioned, the shield is made of a special insulating material, a mixture of fibers called EvaCode, which will protect the spacecraft from this extreme heat. The spacecraft's speed will gradually decrease and its parachutes will deploy, allowing the capsule to fall into the Pacific Ocean and float to the surface. Navy rescue teams will be waiting with ships and helicopters to retrieve them. Once the crew has exited the capsule, the mission will be complete, officially. Once I understood what was going to happen, I wondered what the purpose of the mission was. Why were they orbiting the Moon? And why was NASA repeating this scenario? The Artemis II mission is part of a comprehensive program. The first Artemis mission launched in 2022, before Artemis II. The general idea behind the Artemis program is that they sent an empty capsule to orbit the Moon during Artemis I before putting humans on these missions. Dummy models mimicking human bones and muscle tissue were used to test the effects of the journey on the human body, as well as to ensure the safety of the spacecraft and confirm that all its internal systems were functioning correctly. They also tested its resistance to heat and radiation. Once the capsule's efficiency had been confirmed for Artemis II, the astronauts were placed inside and it was launched towards the Moon. Artemis III, scheduled for launch next year, will involve testing the docking process. Artemis IV will see them land on the Moon, with Artemis V and subsequent missions focusing on building bases on the lunar surface. What is the difference between the Artemis and Apollo missions? Put simply, it lies in their sustainability plans. While the Apollo missions were designed to answer the question of whether we could reach the Moon, the Artemis missions will address the question of whether we can colonize it. The Artemis program's current goal is to establish a permanent lunar orbiting station, similar to the International Space Station orbiting Earth. This station, known as the Lunar Gateway, will enable future spacecraft to travel from Earth to the Moon indirectly. They will dock with the lunar station, and once inside, the astronauts will leave their spacecraft and board a small rover designed specifically for the station. This rover will then land them on the Moon and take them back to Earth. After completing their mission, they will return to the station and fly back to Earth in their spacecraft. This will establish a permanent lunar trajectory, facilitating easier human travel to and from the Moon while reducing the cost of long-term space travel. Eventually, it may even be possible to establish a settlement on the Moon. Their second and most important objective is mining. The US has explicitly stated that they want to use the Moon as a mine to extract precious metals. They believe that once the first metal has been extracted, the costs of round-trip missions will be fully covered, opening the door to enormous wealth for large corporations and business people. Companies such as Amazon and SpaceX have ambitious plans to build robots that can mine on the Moon's surface. In another episode, we will discuss this topic in more depth and consider whether it is possible. And that's all for this episode. Thanks for watching. I hope you enjoyed it. See you in the next one.